Hi, turkeys. I am making this for you for class today. Okay, so first of all, here is your first slide. Um, and the warm up is on a Google form again. So please do that. And then whenever you're ready, we're going to review some ocean currents. Okay, but you can pause it until then. Okay, so currents. We talked about this last time. We have deep ocean currents and surface currents. You might want to get your notes out from last time. Um, Cold water has high density, and high salinity also means high density. Remember, salt water has that salt in it that makes it heavier and more dense, so it sinks to the bottom. And cold water will do that as well. Then we have thermohaline currents. So you guys did this in your warm-up. So thermo is heat and halo is salt. So they are very deep currents. They move slowly and they distribute nutrients like salt and also heat. I don't know if heat's a nutrient, but they distribute them throughout the ocean. Okay. And they do regulate global temperatures. They're not just the water temperature, but they regulate global temperatures. Okay, I'm going to make this bigger for y'all. Okay. Thermohaline. Okay, so now that I just closed that, y'all are going to open it. Open this. Okay, and you have this thermohaline currents. Okay, so please get that out, and that's what you're going to be filling in here. Okay. Thermohaline current occurs deep within the ocean. This is a picture of it. Okay. It acts like a conveyor belt as the ocean, they absorb, store, and redistribute heat from the sun. Okay. Without this, places at the same latitude would have the same temperature, but they don't. Okay. The example here is Norway and Canada, that they have different, but there's also, let's see. If you look at your paper, it'll tell you San Francisco and Norfolk. So San Francisco and Norfolk, Virginia, they're at the same latitude, but San Francisco is, it basically has its own seasons. It never snows there, but it also never really gets hot there. And then Norfolk, Virginia is more like how we are. It's more, it does snow there probably, and it also they have pretty hot summers, and that is because of the Gulf Stream that comes over here, and it brings warm air. Madrid and New York City. So New York City is up here, and Madrid is over here. It snows in New York. Doesn't happen in Madrid, right? Boston and London are kind of the same. They're at the same latitude. And again, it doesn't snow very often in London, whereas it really does snow. They have long winters in Boston. And also, Portland, Maine and Cannes, France are at the same latitude, which I didn't know. And that's also because of the water. So not all of these are necessarily because of the thermohaline current, but it does affect a lot of this. Okay. All right, so thermohaline circulation is driven by the differences in density. In the Pacific Ocean, over here, we have warm water, and it comes over to the Atlantic, okay? And it's warm, so it's shallow, so it's not deep, okay? Because it's less dense, and it sits on top of that cold water. And then cold water from the Atlantic Ocean moves to the Pacific Ocean, right here. From the Atlantic moves to the Pacific. And this cold water is deep. It's more dense, so it sinks way down to the bottom, and it is very deep. Okay, so that is about halfway on this little thermohaline current page. Okay, and then as the current passes Europe, the surface water evaporates and it heats the atmosphere. Okay, so it gets into the clouds and the atmosphere. And this is why Western Europe is warm, especially in the summer, like Rome and Italy and even France. They can be very warm, but they are way up here. If you think about it, they're much higher than like Austin. Let's see. As the thermohaline current increases in temperature, there is an upwelling. And we said that an upwelling is when cold water from the bottom comes up and it brings all the nutrients with it. Okay, now you're going to fill this part in here. When the current passes the polar oceans, the surface layer gets colder and saltier. It slows down as it increases in salinity because, again, it's more dense. So heavier things move slower, more dense things move slower, and it becomes more dense. Increases in salinity and becomes more dense. This increase in density causes the surface water to sink. Then it says that the water gets saltier because that warm surface water on top evaporates, but the salt doesn't evaporate with it. And also, when the water freezes into the glaciers, it leaves most of the salt in the water. Okay, so that's why we have changes in salinity as well as temperature. Okay, looks like this is at the very bottom of your little handout here. And then the thermohaline current, aka the ocean's conveyor belt, is largely responsible for the variation in climates around the world. Global climate changes could change how the thermohaline current operates. It could alter or completely stop depending on how the climate is changing. And I'm not sure if you guys have seen the movie The Day After Tomorrow, but they talk about salinity a lot in that movie. Obviously, that's not a documentary; it's a science fiction, but it's still pretty interesting. Okay, we are going to set up our journals next class, and right now we're going to do these next class. Okay, maybe we'll even do them for our warm up. Okay, now I would like you to look at this extreme weather web quest. Okay, this is awesome, and Mrs. Mitchell made this, but a lot of the sources were Wikipedia pages, and I'm making this because I'm not going to be here to help you with it. I think if I was here, we could figure this out and we could talk about it, but I'm not. So we're not gonna worry about that. We're just gonna kind of do this together. Okay. Okay. So have that out, and we're gonna watch this video together. Yay. Okay, so Central Texas gets an average of 50 to 60 thunderstorms a year. I found that online. And up here, I had these, like a word bank for you. So it goes multi-cell, supercell, squall line, and single cell. Okay. Warm air meets cold air. So in a multi-cell thunderstorm, it doesn't always happen over a mountain, but it's whenever warm air mixes with cold air. It happens here when we get like some cold air from Canada in the winter, and it mixes with like warmer air from the Gulf. Whoops. Supercells, they occur at coastal areas in the tropics and subtropics, monsoon winds, and these thunderstorms occur because of wind shear. And this is when wind is changing speed and direction. We can get a squall line thunderstorm when air masses are mixing at low levels. It's on the leading edge of the cold front. Okay, so that would be like the whatever direction it's moving. And then we can get single cell thunderstorms where we have low wind shear and moderate instability. They come at the leading edge of a warm front, and they're usually kind of small, single cell. Okay, I'm going to change to this. Okay. Ooh. Okay. So let's talk about how they develop. The developing stage of a thunderstorm is marked by a cumulus cloud, which are the big, puffy, happy clouds, and it gets pushed upward by a rising column of air, which is updraft. They talked about that in the video. Okay. I feel like I'm an expert on storms because I grew up in Houston and we have all kinds of them there. Okay, when the updraft continues and it feeds the storm, but precipitation begins to fall out of the storm, creating a downdraft, which they talked about in the video, and they showed us that nice visual, the thunderstorm can enter the mature stage. And this is the dangerous stage, right? This is when we get hail, lightning, heavy rain, and tornadoes. Eventually, a large amount of precipitation is produced, and the updraft is overcome by the downdraft, beginning the dissipating stage. So, dissipating means that it's kind of going away. A very large thunderstorm is known as a supercell. And a supercell is characterized by the presence of a mesocyclone. And it is a deep, persistently rotating updraft. Sounds like a tornado. And a tornado is at the very end of it, but the whole thing is called a mesocyclone. Wind shear is an atmospheric condition in which changes of speed and direction of the wind occur. And you see this all the time. If you ever look at the trees, like when the wind's really blowing and the trees are like showing their underside of their leaves, or like you can really see it like blowing dirt up, you're having some wind shear. So, and it's usually going to really rain. Okay, next part here is severe thunderstorms. You guys all keeping up on your sheet? Okay, so strong winds. I'm going to move myself up here so that you can see my video or my diagram. Severe thunderstorms. We have torrential downpours. 12, we have strong winds at greater than 58 miles per hour, very specific. Okay, it's 57, not a severe thunderstorm. Hail 1 inch in diameter or larger. Sometimes it can get really crazy big. and we get cloud to ground lightning. So I know we know what lightning is. It's a sudden spark or energy discharge caused when electricity jumps between parts of a cloud or just from the air or between the cloud and the ground. So it can do a lot of different things. But this is cloud to ground lightning in a severe thunderstorm. Okay, tropical cyclones are hurricanes. Again, right now there is an enormous hurricane coming, at least at the time that I'm recording this. It's enormous. I'm really kind of scared about it. I'm afraid it's going to be like Hurricane Katrina. Anyway, tropical cyclone is a huge rotating storm with powerful winds and heavy rain. Forms over warm water because it heats the air above it. Okay. And tropical cyclones form when low, warm, moist air over the water rises and it's replaced by colder air. Okay. So this warm, humid air is not dense, right? So it wants to rise. And then it gets replaced by colder air that wants to come down here because it is dense. Okay. If you turn your paper over, here's this picture. And this is a really interesting picture. This is a hurricane. So you can see the cold air up here and then the warm air rising. Okay, and these are the cloud bands. These are cirrus clouds. Here's the outflow. And then we also have, inflow? No, upflow. We have the rain bands here. Okay, and you see these, you can really see them on the news. Then this is the eye of a hurricane, and it's kind of like a cyclone in the middle. I was just reading something really interesting that said sometimes birds can get stuck in there, like a flock of birds, and they can't get out. Really interesting. And then the eye wall is just like a cloud. So it's like a cloud funnel. And the storm rotates clockwise in the northern hemisphere. Remember, because of the Coriolis effect, it will rotate counterclockwise in the southern hemisphere. Okay, so the next question says, where do most tropical cyclones occur? So they start in these warm waters right by the equator, right? You don't see any of this up here in the Arctic or the Antarctic, right? So I just kind of drew those on my map. And it says, why do you think that is? Because they need that warm water. And like we said, it doesn't happen where there's cold water. When the ocean level rises at the coastline because of the strong storm, it's called the storm surge. Look that up about this hurricane right now that's in the Gulf. And the tropical cyclone ends when it gets cut off from the warm, moist ocean air, which is usually when it hits land. You'll see this one, as soon as it hits land, it goes down in category, and then it's going to kind of jump over Florida, and then it could get big again when it jumps over Florida. It does that a lot when it comes over like into the Gulf. It'll get a little smaller, and when it hits that land, and then it'll get bigger again. So, okay, make sure you answer all the questions and do the formative. Oh, both this Ed puzzle and the formative are for a grade. And I hope that you watch this a little bit sped up. Also, remember, if you want to do test corrections, you got to turn them in by Thursday at 4:10.